So recursive formulas for arithmetic sequences. And that is pronounced, oh, sorry, I don't have my screen on there. This is pronounced arithmetic, not arithmetic. Okay, in this context, it's arithmetic. I honestly don't care as long as you know that word, but if you want to sound like you know what you're talking about, okay, it's arithmetic. So an arithmetic sequence is a specific type of sequence, but then remember, for every sequence that we ever write, there's two different ways that we can write the formula. There's a recursive formula and an explicit formula. So real quick, with someone at your table, will you see if you can remember the difference between an explicit and a recursive formula? Okay, just talk to someone next to you real quick. See if you can remember the difference. All right, who thinks they can help me out with the difference between the two? Or even if you just remember one of them, how one of them works. What do we know? Oh man, you were all talking to each other. Somebody talk to me. This has happened every hour today. No one wants to talk to me. Okay, someone remind me, explicit formula. How does an explicit formula work? What do you plug into an explicit formula? Okay, so you're kind of mixing two things there. There's previous term or there's term number. Which one goes with explicit formula? Term number. Okay, so an explicit formula is where you're plugging in an n value. You're plugging in, I want term number 5, I want term number 12. Okay, this right here is a recursive formula. How does a recursive formula work? It links terms together by finding what? Yeah, what's happening to the previous term, right? See, I knew you guys knew this. All right, so an explicit formula is where you just plug in a term number. A recursive formula is where you're saying what happens to get from term to term to term. And so today we're really just focusing on the recursive formula for this type of sequence. So if you haven't written that down yet, let's go ahead and write that down. An arithmetic sequence is a sequence generated through addition. Okay, a sequence generated through addition. And I'll show you real quick what I mean by that. An arithmetic sequence might look something like this. Okay, 3, 5, 7, 9, 11. If you were just going to describe this sequence to me, just informally, no like math talk, what would you say about that sequence? What's happening there? Matt? Okay, it is odd numbers, that is true. Okay, how else could we say it? Let's say it wasn't odd numbers, it was just a random pattern of numbers. What else could we say, Gabby?
You add 2 to the previous.
Yep, so you're going up by 2 every time, right? You're adding 2 every time, okay? That's what makes this an arithmetic sequence, is that the next term is found by doing some sort of addition over and over again, okay? Whereas if you had something like this, 2, 4, 8, 16, 32, how would you describe that sequence? Yeah, you're multiplying by 2. That is not an arithmetic sequence, okay? Because that's not growing by addition, okay? Now, what's going to happen in just a minute, and I caught this second hour, this confused them, so I'm going to try to catch you early on this. In example 2, we're going to write one of these, but instead of adding every time, we're going to subtract. Subtracting is still okay, because subtracting is really like adding what? Yeah, a negative. Adding a negative is really the same as subtracting. So when I say generated through addition, subtraction is okay too. And you're going to learn that in math, addition and subtraction are really kind of the same thing. Okay, you've always learned them as being different, but as you get higher and higher up into math, addition and subtraction kind of work the same way. Okay, so subtraction is okay as well. All right, so let's take a look at that example 1. consider this sequence. Here's a recursive formula for you. So that's what a recursive formula looks like. And I just want to know what's happening in this sequence. See if you can describe it in words to the person next to you. And then just be forewarned, I'm going to make you talk to me. So what's happening here? What is this talking about? Okay, somebody raise a hand and talk to me about this one. Go ahead, Abby.
You're adding 6 to the previous term.
Okay, so I am adding 6 over and over again. There's another important piece. Haley?
You start at 25.
Good. So we want to make sure we get both of those things when we describe in words. That we're starting at 25, and then we're adding 6 over and over again. Okay? So what that would look like is you'd start with 25, and then you'd add 6 to get to 31, add 6 to get to 37, add 6 to get to 43, and so on. Is that all I need? Yeah, there's 5 there. All right, little bit of terminology here for you. This number that you're adding over and over again, like it shows up here or it shows up here, that there is called the constant difference. Okay? Constant difference is that number that you're generating your sequence with, that number that you're adding over and over again. Now, this threw some people second hour also, so again, I'm going to try to catch this now. It's always called a constant difference. I know that you're used to hearing difference and thinking subtraction, but if I say that it has a constant difference of 2, that means that it's going up by 2 every time. If I say it has a constant difference of 5, that means that you're adding 5 every time. If I say it has a constant difference of -3, that's when you're subtracting. Does that make sense? So it's always going to be called a constant difference. And you always want to assume it's addition. And then if I want you subtracting, we'll just make it negative. Okay? And then also, I don't think this actually comes up today, but just so you recognize it for tomorrow, we're going to use the letter D to represent that when we write formulas. Okay? So we're going to write some formulas with this, and we're going to use the letter D to represent that constant difference. Okay, so let's read this next problem. Brianna borrowed $3,000 from her parents for a trip to Europe. She plans to pay them back $50 per month. Write a recursive definition to represent the amount she still owes. So how much does she have left to pay after n months? Now, there is one piece of this that's a little bit tricky, okay? So obviously, we're starting with $3,000, right? That's the initial amount. If you think back to when we wrote linear equations, we're starting at $3,000. But when we go to say what term 1 is, we really have to think about what term 1 should represent, okay? If it's after n months, then term 1 should be after the first month. Do you agree with me there? That if it's defined as n representing the number of months, and it says after n months, then T1 should be after month number 1. Does that make sense? Why does that make a difference? That we think of it that way. Why does it make a difference for me to say that T1 is after the first month? After the first month, do I still owe $3,000? What do I owe? There we go, $2,950. So when I go to write T1, I want to make sure that I'm not using that $3,000, that I'm using what does she actually owe after the first month. Okay? And sometimes you have to make that adjustment, sometimes you don't. It totally just depends on the way the problem is worded. I don't have like a hard and fast rule for you for when you have to do that and when you don't. Okay? I would just always think back to what should T1 represent the way my problem is worded. Okay, look on your homework today. I know on the back side of it, there's 2 word problems back to back where in one of them you have to do this and one of them you don't. Okay, one of them you can just pull the number right out of the problem. So it just depends on how it's worded. And then to get the rest of my formula here, I'm always taking the previous term. Remember that notation? T sub n minus 1 just means previous term. There's no math involved there. And what am I doing every month to the amount that I owe? Subtracting 50. Good. And so when I say write a recursive definition, you do have to make sure you have both of those parts there. Okay? Everyone good with that? Okay. This next part, we're going to sketch a graph, and it's going to be a real rough graph. We're not going to like number it nicely or anything, but I just want you to see how this relates to linear equations. So if I were going to draw a graph here, okay, this would be my number of months down here on the x-axis. And this would be how much I still owe. So when I'm starting, when I'm here on the axis, what's the initial amount that I owe? That's going to be my 3,000, okay? I am starting at 3,000. That's just not term number 1. That's like term 0. So I am starting at 3,000. And then here's where I would go. Here's month number 1. Here's month number 2. Here's month number 3. And so on. Okay? And then every month I'm going to come down $50. So this would be at $29.50. This next one would be at $2,900. This next one would be at $28.50. Whoops. And so on. Okay, now I'm not even following my lines at the bottom, but can you see that it's going to do something like this? Right? It's going to come down by 50 every time. And so you have sort of a linear pattern there. And that's how this is going to relate back to linear equations. Feeling okay on that? But again, the important thing to get is that 3,000, that's how much you're starting at. But term 1 is actually at month number 1. So the $29.50 is actually term 1. Good there? Okay. Homework for today then is out of your packet. It is Lesson Master 3.7b, and you've got the rest of the hour to get started on that.